Question 106 is using the fundamental theorem of algebra. So the fundamental theorem of algebra just states that every polynomial of degree n greater than or equal to 0 has at least 1 0 in the complex numbers. And this includes multiplicities. A polynomial function of degree n greater than or equal to 1 has exactly n zeros. So we're going to write all of that out. Fundamental theorem of algebra states every polynomial of degree n greater than or equal to 1 has at least 1 0 in the complex numbers. And then the corollary to that theorem just says, including multiplicities, a polynomial function of degree n greater than or equal to 1 has exactly n zeros. So hopefully you remember that complex numbers include all the real numbers. So 3 is a complex number. And 4i is a complex number. And 3 plus 2i. So those are what complex numbers are. So every polynomial has at least 1 0 in the complex numbers. So we're going to look at some examples. I'm going to give you a polynomial. We're going to write it then factored. Then we're going to write our roots and how many roots we found. So if our polynomial is x squared minus 16, that's a difference of two squareds. So we have x minus 16, x plus 16, which means our roots, not 16, 4. Okay, thank you. So the roots are plus and minus 4, and there's 2 of them. X cubed minus 5x squared plus 8x minus 4. Factored is x minus 1, x minus 2 quantity squared. So the roots are 1 and 2. 2 has a multiplicity of 3, so it's exactly 3 zeros. However, since 2 is doubled, oh, I have down 3 roots. And that's because 2 has multiplicity of 2. Dang it. I do not want to throw this pen away. It's my favorite. All right, how about x to the 5th minus x to the 4th minus 2x cubed? So when we factor out the x cubed, that means 0. It's going to have a 0 at 0 with a multiplicity of 3. So we have 0, negative 1, and 2, but this has multiplicity of 3, so there's exactly 5 roots. And we could continue on. You can use a graphing calculator to find the real roots, which then helps you factor the polynomial that you're given. Okay, so sometimes it's just looking at it, it's hard to know how to factor it, but if you know what the roots are, that will help you to factor it. And then you can find the complex roots once you can figure out how to find how you factor it. So we're just going to write down, use the graphing calculator to help find, to help factor polynomial by finding the real roots. Once you find the real roots and you can factor it, then you can see if there's any complex, other complex roots. So, you know in a parabola where it can either cross the x-axis twice, it can sit on the x-axis and cross it once, or it doesn't even cross it at all. So since it's a quadratic equation, it has to have exactly 2 roots. So if it's not touching at all, it's going to have 2 complex roots. So it won't have any in the real numbers. They'll be complex. And then if it just touches once, then it's 1 root with a multiplicity of 2. And then if it crosses twice, of course, it's 2 roots. When the root has an even number. Oh. I don't know what this means. If I write it, maybe you guys will know it. It says okay, this is what it's saying. If you have a graph that has an even number multiplicity, like a multiplicity of 2, 4, 6. So if it has an even numbered multiplicity, it will always touch and not cross. So that's like when the quadratic is sitting on the x-axis. It doesn't cross it, it's just sitting on it. So it goes down, touches it, and comes back up. That would have an even number multiplicity. But if you have an odd number multiplicity, then it's going to cross at that 0. So it will go through. So it could be, so if you have a graph that crosses the axis, it could have a multiplicity of 1, 3, 5, etc. Okay, that's the end of the lesson. We're going to do